let's review one-step equations to make sure that we have that fresh in our brain. So the first thing you do with your equations is you want to change subtraction to addition and division to multiplication. So number one here, we're going to change the subtraction to addition by adding the opposite, or keep change opposite. Now, what should I do next? I should add the opposite of negative 15 to both sides. And that gives me x plus 0 equals what? What's negative 20 plus 15? Negative 5, right? So x equals negative 5. Next, let's try a division equation. Well, I mentioned we're going to change division to multiplication, so what would we change x divided by negative 4 to? Negative 1/4 times x, right? And now what should we do to both sides? We're going to multiply by the reciprocal of negative 1/4, which is what? Negative 4. And we end up with 1 times x equals negative 32. So x equals negative 32. So what we learned with solving one-step equations is if you have addition, you add the opposite to both sides of whatever number is being added to x in order to solve. If you have multiplication, you multiply by the reciprocal on both sides in order to get x by itself. And if you will remember, the whole reason we do that is to end up with this identity step that it's okay to do in your head, but it's important to understand. With addition, we want to end up with x plus 0, and with multiplication, we want to end up with 1 times x, because that's how we're going to get our x by itself on the left-hand side, and then whatever we end up with on the right-hand side is our answer. So when we work with two-step equations, this is really a multiplication equation and an addition equation put together. So all we're going to do is apply the steps we've learned for multiplication and addition equations. So the one thing you have to keep in mind is what order to work with. In other words, which would you work with first, the multiplication or the addition? Well, you might think multiplication because of order of operations, but we're actually going to work with the addition first. And a way you can think about this just to help you remember is think of it as undoing the problem. So we're kind of going backwards with our order of operations. We're going to get rid of addition, and then we're going to get rid of multiplication. And actually getting rid of multiplication will be our very last step. So how would we let's think of this equation as just x plus 4. If this equation was x plus 4, what would you do to get rid of that 4? You'd add negative 4 to both sides, right? Well, that's exactly what we're going to do here. Only it's 2x plus 4. But that's okay. We're still going to start with adding the opposite of 4 to both sides. And when we do this, we end up with 2x instead of x. When we bring down the x, we bring down our plus. 4 plus negative 4 is 0. 6 plus negative 4 is 2. 2x plus 0 gives us what? 2x, right? So instead of x plus 0 equaling x, we get 2x plus 0 equaling x. We bring down our equals, we bring down our 2. Now we're left with a one-step multiplication equation. And this is typically your last step when you're working with two-step equations. Your last step will be working with what looks like a one-step multiplication equation. So how would you solve that? You multiply by the reciprocal of 2 on both sides, which is 1/2. And when we do this, we're going to do a little cross-canceling. And we end up with 1 times x equals 1 times 1. You can skip that step if you'd like and go straight to x equals 1. And of course, we can check this by substituting our answer 1. I like to put this in parentheses to emphasize we're substituting in the place of x, and seeing if we get a true statement. So does 2 plus 4 equal 6? Yes, so we have the correct answer. So let's talk about the basic steps for your two-step equations. First, you change subtraction to addition and division to multiplication. So I have an example here, and let's do those changes, apply those changes. So we would end up with, in this case, negative 1/3 x plus negative 4. So I changed division to multiplication, subtraction to addition, equals 5 plus negative 6. The next step is to simplify both sides by adding like terms, constants with constants and coefficients of same variables together. Well, we do have some like terms in this problem that we can add together, the 5 plus the negative 6. On the left-hand side, there's no like terms that we can add together. So for this step, we're going to write down negative 1/3 x plus negative 4 equals, what's 5 plus negative 6? Negative 1. Very good. So the next step is add the opposite of whatever's being added to the variable to both sides. We're going to work with that opposite property. So for our next step, we would take that same equation and what would we add to both sides? If you think we should add 4, you're absolutely correct. And then we'd simplify, and we'd end up with negative 1/3 x equaling 3. The next step is to multiply the reciprocal of whatever is being multiplied by the variable to both sides. So what's being multiplied by the variable? Negative 1/3. So what's the reciprocal? Negative 3. We multiply both sides by negative 3. And x equals negative 9. I skipped the identity steps, but this is your basic process for working with two-step equations. Some problems will be harder and have some tricks in them that are a little more challenging than what we see here, but this is your basic problem that has 2 steps to it. And the reason we say 2 steps, even though it really took more than 2 steps, the 2 steps we're referring to is the step where we're adding the opposite to both sides and the step where we're multiplying by the reciprocal on both sides. I'd like you to try this next problem. Unless I give you decimals, if you end in your problem, if I give you decimals in your problem, then the answer should be in decimal form. But otherwise, if you end up with a fraction as your answer, go ahead and leave it as a fraction. So we need to change subtraction to addition. That's always our first step. And any division to multiplication, but that we don't have any division. The next step is to add the opposite of whatever's being added to your variable. Add that to both sides. And then simplify. So here's our simplified step. And then the next step would be to multiply by the reciprocal of whatever's being multiplied by x on both sides. And get your final answer, which is negative 4.5. Now, one thing that I'd like you to notice in this problem is that the last step ends up being the step where you multiply by the reciprocal on both sides. So you should end up with a one-step multiplication equation as your as the last part of your problem before you multiply by the reciprocal. So multiplying by the reciprocal on both sides is almost always your last step. There'll be some exceptions, but typically it's your last step. Now keep in mind here that x has a negative in front of it, so that's negative 1 times x. So I'd like you to try to solve this problem. So I've completed the steps almost to the end here. I haven't quite finished this problem. So my first step here was adding the opposite to both sides. So add a negative 5 to both sides. Now I put a negative 1 in front of my x. I really didn't need to do that, and as you get higher in math you will not do that. However, I wanted to emphasize a point today. So after I add negative 5 to both sides, I end up with negative 1x equals negative 22. Now, in order to finish this problem, we're going to have to make that x a positive x. In other words, if you end up with negative 1x or negative x as your last step, you can write it either way. Again, you'll write it as negative x as you get more advanced in math. This is not the answer because this is saying the opposite of x is negative 22. So if the opposite of your answer is negative 22, then what should your answer be? It should be positive 22, right? Then x must be positive 22. However, you can't just conclude that without showing why. So you're going to have to show me a step here. So at this point, you're going to have to either multiply, well, you're going to be multiplying by the reciprocal on both sides. So let's think about that for a second. So that negative x actually means negative 1x. So what is the reciprocal then of negative 1? Remember, reciprocals are numbers that multiply together to equal positive 1. So what's the reciprocal of negative 1? It's negative 1, isn't it? So what you're going to do is multiply both sides by -1, and that indeed will give you positive x on the left and 22 on the right. So make sure you show me that step. I always need to see what you're adding on both sides and then what you're multiplying on both sides. Those are key elements to showing steps for solving equations. Try this next problem. Please remember to change subtraction to addition, division to multiplication, and you might want to consider putting the right-hand side of your equation on the left-hand side and vice versa. The first thing I did is switch this problem around so that my variable's on the left. Just remember to keep the entire sides together. So the side with the m, I want to keep that whole side together when I flip it around to the right side, and the side with the -16, I keep that by itself when I flip it around. My next step is to change division to multiplication, so -m/4 becomes -1/4 m, and change subtraction to addition, so that -7 becomes plus a -7. Then I'm going to deal with that adding a -7 by adding the opposite, and I have to add the opposite to both sides to keep the equation balanced. So I end up with -1/4 m plus 0 equals -9. Again, you can skip this step and go straight to the following step if you'd like. So that simplifies to -1/4 m equals -9. I multiply by the reciprocal, which is -4 on both sides, and my answer, I get 1 times m equals 36, and my answer is m equals 36. And I could check this by putting 36 up in the place of my variable. So it is important to understand how to check all these. So the opposite of m is really important here. So we ended up with 36 as our answer. So we're going to put the opposite of 36, or -36, in the place of m over 4 minus 7. So notice I keep all my original notation so that if I made a mistake changing any notation, I can catch it at this point. So -16 equals -9 minus 7. -16 equals -9 plus -7. 9 and 7, 16, same signs, gives me a negative, so I have the correct answer. Give this next problem a try. Okay, so in this problem, I'm going to start by flipping the sides around because I like to have my m on the left-hand side. And if you want, you can skip straight down to the second step. I'm just making sure this is very clear. So you don't have to show this step right here, or you can. It depends on what's helpful to you. So I end up with -2/3 m plus -8 equals 0. So I start with getting rid of addition. So I add 8 to both sides, get rid of that -8, and I'm left with -2/3 m plus 0 equals 8. Again, you can skip this step right here, the identity property step, or you can complete it, whatever's easier for you. And that simplifies to -2/3 m equals 8, so we multiply by the reciprocal of -2/3, which is -3/2. And if we do it to one side, we have to do it to the m equals 4 times -3 in the numerator over 1. Again, you can skip this step if you'd like and go straight to the answer. M equals -12. So I went ahead and did a check step. I substituted -12 in the place of m in my original equation and divided by 3, and that ends up equaling positive 24 divided by 3, which is 8, and 8 minus 8 does indeed equal 0. So here's our entire problem. And as a quick review, remember all these steps when solving.